In this video, we're treating the subject matrix. A matrix is a simple mathematical structure that holds numerical information in a rectangular form, usually enclosed by brackets. A matrix is a simple mathematical structure that holds numerical information in a rectangular form, usually enclosed by brackets. So when we're talking about matrix, we're talking about representing information in rectangular brackets, and that information represents a set. It's usually vital information. Take a look at the example. A college has its number of students in each of the SS classes classified as follows. The SS1 class is a column for male, is a column for female. So in SS1 class, there are 14 male students and 8 female students. SS2 class, we have 6 male students and 12 female students. For SS3 class, we have 21 male and 18 female. Now this is just information. We can represent this information as using metrics. So the above information can be represented in matrix form. In matrix form, we say matrix A. We give it a matrix and we call it matrix A is 14, 6, 21, 8, 12, 18. Now this information that we have here has been represented in the form of matrix. Now where the rows? In this matrix, we have rows. Rows are horizontal lines going from left to right, and columns are vertical lines going from top to bottom. So if you have A, B, C, D, E, F, G, H, I. If we have this as matrix, let's see, matrix A. We have this as matrix. If you are going from left to right horizontally, we're going from left to right like this. Let's see, we're going to left to right like this. This is called rows in matrix. And then if we are going from top to bottom like this, this is our starting point. If you are going from left to right, it's called rows. Same thing applies here. This row to the first row, so we call it first row. In second row, and then this is third row, and then if you are going from top to bottom, we call it column. So this is our first column, and this is called first column, and then this is our second column, and then this is our third column. So matrix is it makes a simple mathematical structure that holds numerical information in a rectangular form, usually enclosed by brackets. And this information that is enclosed in brackets is described by rows and columns. And these rows and columns, they have numbers. So let's go on. So where the rows represent the classes, you can check our classes. Okay, so SS1, so the classes, the rows in this matrix represent the classes. So this is 14, SS1, SS2, the classes, SS3 class, and the columns represent the sexes of the teachers. So this column represents the sexes of not the teachers, of the students, the sexes of the student. Okay. So, and columns represent the sexes of the student because the the matrix here, or this information, is about students. The college has the number of students in each of the SS classes classified as follows. So, is the sexes of the students. So the rows talks about the classes, tells us about gives us information about the classes. The columns give us information about the sex of the sexes of the students in each of the classes. Okay, so generally, matrix is written in the form A equals to E11, E12, E13, E21, E22, E23, E31, E32, E33. We can have matrix B equals to B11, B21, B12, B22. This type of matrix is called 3 by 3 matrix, 2 by 2 matrix. We'll learn more of this when we start looking at types of matrix. But generally, a matrix is written in this form. This part here is known as matrix of E question. Now these letters, or what you have inside the bracket, the letters, the values enclosed in the brackets, they are called elements of matrix A. The elements are written in lowercase while the matrix is written uppercase. So you don't write matrix like this. Matrix A is equals to E11, E12, E21, E22. It's not, you don't write it like this. It's wrong. You don't write it like this. Rather, the matrix of E, the E is usually capitalized. If it's matrix of M, the M is usually capitalized. Then the letters are in lowercase. It can be N11, N12, N121, and N22. That's way. So you can see that the matrix of A is written in capital letters and elements are lowercase. B is the capital letters and the elements are in lowercase. Each of these elements represent values. So when I will start taking matrix properly, you will understand why what these letters and the numbers mean. So okay, so generally matrix written in the form A equals to this, B equals to this. This type of matrix is called 3 by 3 matrix, and this is called 2 by 2 matrix. As I have explained earlier, this, if you are coming from left to right, this way is called rows. So U11 from this matrix, E12, E13, and then come to this B11, B12 coming from top, from left to right like this, from left to right like this, called rows. And if you're coming from top to bottom like this, top to bottom like this, we call it column. So E11, E21, E31, that is this part of the matrix, and this part of matrix B, they're called columns. The matrix with n rows and n columns is called an n times n matrix. But what does the n times n? The n times here means by. So we say where m times n or m by n. So in written forms n times n, but it's pronounced as n by n. So where m by n or m by n is called the size or shape of the matrix. So examples, matrix B. Let's check. Matrix B has one. These are rows. First row, second row, third row. So 3 rows and the first column, second column, third column. So we have 3 rows and 3 columns. So we call it a 3 by 3 matrix because it has 3 rows and 3 columns. Matrix C, 3 rows, 1 first row, second row, third row, first column, second column, third column. So we call matrix C a 3 by 3 matrix also. Matrix D has 2 rows and 2 columns. So we call matrix D a 2 by 2 matrix. Let's look at matrix E. Matrix E has 1 row, two row, third row, sorry, first row, second row, and the third row, and just one column. So we call it a 3 by 1 matrix. A 3 by 1 matrix is also a column matrix because it's just a column. And matrix F has one row but 4 columns. The first column, second column, third column, the fourth column. So we call it a 1 by 5 matrix. So the order is that the row comes first. So matrix with m rows, the rows come first, followed by the columns. So if you look at it again, you discover that the row usually comes first. So let's take note of the row. 3 by 3 matrix, 3 rows, 3 columns. 2 by 2 matrix, 2 rows, 2 columns. Column matrix of 3 rows, that's why you have 3 by 1 column. One row, this is the row matrix, 1 row and 5 columns. So then matrices are usually denoted, I said that earlier, matrices are usually denoted by capital elements, while they are elements by capital letters. Matrices are usually denoted by capital letters, while their elements are in lowercase, are usually denoted by letters in lowercase. So, for example, the matrix B is written as B, where B is in uppercase, as capital letter, and not B. So you don't write matrix like this. It's not the matrix of B, where the B is in lowercase, and also the elements are in lowercase. The elements are supposed to be in lowercase, which in this case is correct, but not this part here in lowercase. It must be in uppercase. So that's what you should take note of. Types of matrix. Zero matrix number 1. Zero matrix is a matrix whose entries or elements are all zeros. So a 2 by 2 matrix, look at it, the entries or elements are all zeros, column, the rows are zeros, the columns are zeros. And all the 3 by 3 matrix, all the entries or elements are zero. So this matrix is known as the zero matrix. Number 2, the square matrix. The square matrix is a matrix whose number of rows is equal to number of columns. So any matrix that the rows are equal to the columns, that matrix will result in being a square matrix. Take a look at this. So we have 2 rows, 1, 2, the first row, second row, and 2 columns. So we have a square matrix, 2 by 2 square matrix. And here we have 1, the first row, second row, third row, first column, second column, third column. So this will result in 3, or this has resulted in 3 by 3 matrix B. So this is 3 by 3 square matrix. Then the non-square matrix, if the square matrix is when m is equals to n. The non-square matrix is when m is not equals to that is when n is not equals to n. So the non-square matrix is when n is not equal to n. So the number of rows is not equal to the number of columns. So matrix C, we have 2 rows, 3 columns. It's a non-square matrix because the rows are not equal to the columns. D is a 3 by 2 matrix. So we have 3 rows, 1, the first row, the second row, the third row, and just 2 columns. So because the rows are not equal to the columns, we have a non-square matrix here. And then number 4, we have the identity matrix. The identity matrix is denoted by the letter I in capital form, capital letter I. So the identity matrix 2 by 2 is equals to 1, 0, 0, 1. And the identity matrix 3 by 2, the 3 by 2 identity matrix rather is 1, 0, 0, 0, 1, 0, 0, 0, 1. So a note that you need to take is this. Take note of the general pattern or order of the identity matrix. This is the general pattern. Don't interchange it. Identity matrices are always in this form. The 2 by 2 is in this general pattern. So 1 comes first, 0, 0, 1. The 3 by 2 matrix is always in this order: 1, 0, 0, 0, 1, 0. So you don't change it. So okay, maybe you feel like saying, okay, maybe you want to write, you can say 0, 1, 0, 0, 0, 1, 1, 0, 0. No, you don't change it. And the rule of thumb is that it must be diagonal. So if you come like this pattern like this, you have 1, 0, 0, 1. When I say diagonal, it means that your 1 is in diagonal pattern. Same with the 3 by 3 matrix, where you have 1, 0, 0, 0, 1, 0, 0, 0, 1. Consider 1 is in diagonal pattern, and that's it. This is the general pattern of the identity matrix. And as I continue, take note that the first pattern, for example, I gave, and said if you have a matrix B where your entries are E11, E12, E13, and then you have E21, E22, E23, and you have E31, E32, E33. What this result means that E11 is the element found in as a result of any operation that you are going to carry out, either addition, subtraction, multiplication, or division, or scalar, whatever operation you're going to carry out. E11 is the element that you're going to get from that operation, or as a result of that operation, either from two sets, so from two matrices. So for instance, you're going to carry out an addition operations, matrix A plus matrix B and matrix E. You're going to do this in the next video, where I'm going to talk about addition of matrices. So if matrix A plus B and you have matrix E, so B is a 3, 4, 2, 6 plus matrix B, so 7, 8, 9, 10. So what it means is that matrix E11 first row, the 1 is first row, first column. This one is first row, second column, first row, second column, first row, third column. This element is gotten from, or the position of this element is second row, first column. Of course, when you look at it, the position of this element means second row. Of course, it's the second row, and this is the first column. So that's what it implies. E22 means the second row, second column. E23 means the second row, the third column. So the position of E in as an element in matrix B is implies that E is 2, 3. That means E is in second row, third column. The position of E as an element in matrix B, E31, implies that E is in the third row, the first column. That's what it means. By the time we start carrying out addition and subtraction and all other operations involving matrices, we discover that if you're going to look for element E11 first row, first column, there's a process you go through. So at the end of the day, your final answer will be you're going to find the first entry in the first row, first column. So you put your say your A11 is 3. The first row, first column will be 3. So if you have 3, 6, 9, 7, 2 minus 3, 4 minus 9, 6. So let's pick a random entry. Let's say A23. How do you look at A23? A23 means the second row, third column. Here's the second row. Here's the second row. The third column here is this column. So A23 is minus 3. A23 is also minus 3. So if I'm looking for A13 in this matrix, it means the first row, the third column. So where's the first row? This is the first row. And what's the third column? This is the third column. So what's the entry? The first row, third column is this. So the first row, third column, the entry there is 9. So that is 9. So let's take another one, which is the last. Let's say A32. A32 means third row, second column. The value you're going to find that occupies that position, that is the third row, second column. So the third row, second column So I'll draw a second column. So this is it. It will take this plus also minus 9. So that's the meaning of this symbol. In subsequent videos, we're going to carry out operations on matrices, and that knowledge of this will be very helpful.